At Mother Earth Organic Mushrooms, growing and harvesting high-quality mushrooms is a fast-paced, non-stop operation loaded with many stages of production. Growing organic mushrooms requires a particular set of components and environmental factors, time, and attention to detail. From what ingredients are added to the compost and how evenly the mushroom spawn is spread, to constantly monitoring bed and air temperatures, a lot goes into producing mushrooms.
This is the beginning of the mushroom growing process. You know, everybody wants to know what makes a good grower. It's your development, your manufacture, and how you process your compost. Compost is a combination of hay, straw, chicken manure, cottonseed hulls, corn cobs, cocoa hulls, anything that is local, anything that is a byproduct or a waste stream of another agricultural entity. Mushroom growers can take those products and turn them into something that has a high value. It takes about 3 weeks to take these raw ingredients, process them, and then turn them into something that will eventually fill our beds and start to turn into mushrooms. Here we're filling. We choose to fill with nets. The net is a very efficient way of applying compost onto the beds. It does two things. One, it preserves the wood underneath. Two, it gives us a nice even way of distributing and getting an even amount of compost throughout all of the beds. The compost comes in on a conveyor. It's an elevated conveyor, so it rises as the beds rise. It shoots it into the end section, and then there's a guy that just stands there and levels it off at the top. It's extremely important that we get an even fill in depth as well as density. The compost is coming in at 73.5% moisture. When it drops onto the nets, it'll form like these tight balls. And you know, it's hard for us to then further process that compost. We need to have good aerated compost.
After the growing beds have been filled with compost, the pasteurization process begins. This step ensures a clean and safe mushroom growing environment.
After we fill the houses, we do what we call a cookout or a pasteurization step, or some even call it the kill step. We're looking to get above 140 degrees in every square inch of compost to make sure that we are properly pasteurizing and killing any competing molds, mildews, diseases, anything else that may happen to get in there. The cookout process takes about 12 to 14 days. After 4 or 5 days, we do what we call our pasteurization step, or our peak heat. Our peak heat is made up of taking the air up to 140 degrees inside of the house for 2 hours. And what that does is it kills, like on the steps where the humans walk, the top 1 inch of compost, and it pasteurizes those areas as well. And from that point on, we have what we call either landing the airplane or peeling the onion. It's a very slow process, day by day, of slowly bringing the temperatures down. Now, if we look in here, you'll notice how hot it is and the amount of steam that's being generated. Here you see the compost after our pasteurization step, or our peak heat. The white that you see growing in the compost is called fire fang, and that's an indicator mold. It tells us that we're processing and that we're doing the job that we're supposed to do during our cookout. And this step will prepare us to eventually introduce the mushrooms or the growing mycelium into the growth process.
The spawning process is a lot like planting seeds in your garden, but instead of seeds, Mother Earth introduces spawn to the growing beds. The spawn will eventually produce mushrooms.
It's spawning day on a mushroom farm, and what that means is that we have our spawn and supplement delivered so that we can broadcast it across the bed, and then we have a spawning crew come in. The spawn that we use is a synthetic spawn. It's ground and then brought to us so that we can distribute evenly. The spawning machine is basically a large auger. It has about 8-inch teeth that hydraulically are spinning, and it's mixing the compost, the spawn, the supplement, and it's mixing it very well so that we get an even distribution from top to bottom. There's a roller that gets put on, and the roller compresses and packs it down so that we can get as tight as we can, and we try and press all the air and the oxygen out of it, because that will help us control the temperatures once the spawn begins to run. This is about 2 weeks after we've spawned, and you can see the white growth. There's a good view of the spawn growing. That's a vegetative growth. It won't produce mushrooms at this point. Our job here is to get the spawn to run within all 100% of the compost. We need to think of it kind of like the root system of a tree, where it's accessing the food to make the food available to the mushrooms eventually.
In order for the mycelium to produce mushrooms, it needs access to food, air, and water. The compost provides food, ventilation systems in the houses provide air, and casing provides water.
After we complete our spawn run, what we do is we apply our casing layer, is what you're watching here. The casing layer is a combination of peat moss, limestone, and water. We use peat moss because it holds about 90% of its volume in water. Mushrooms require three things. They need food, which is your compost. They need air, which is our air duct systems. And they need water, which is introduced either in the form of the amount of moisture in compost or the amount of moisture in the peat moss. We used to have to carry all these buckets in. And this is an old trolley system that was used in mines. Without, reinventing the wheel per se, how can we get that material in here the most expeditious way possible? And it was, we just stole it from a mine.
Once casing is complete, Mother Earth encourages mushroom growth by carefully controlling and monitoring temperature, moisture, and air conditions.
Once we get our case hole done, we do what we call a flush. And what that does is it takes the mycelium and it converts it from a vegetative growth to a productive growth. And we do that by shocking the system. And how we shock our system is we lower the air temperature drastically, we start raining like crazy, and we change the breathing environment. We drop the CO2 from around 10,000 parts per million down to about 1,200 parts per million. We stress the environment. We create an environment where they feel like they need to start pushing out the pins or pushing out the offspring, which become the mushrooms. In this house, you can quickly see a kind of an indication or an example of what happened. Pin day 0 was P0. You can look at the air temperatures that we were dealing with. You can see the amount of water that we started to just pour on top of the heads of the growing mycelium. If you dig up and you pull that out, you can see here, you can see this stranding. Prior to the flushing process, this would have been a very fuzzy stranding. At the top of every single one of these more defined strands, you're going to then become a pin or a nodule. And you can see those forming right there at the top.
1 week after pins appear, the growing beds are completely covered by mushrooms, almost ready for harvest.
This is 7 days later. We're only 6.5 weeks into the growing cycle from when we first filled our mushroom house. From the smallest pins, now you can see properly formed mushrooms, which will be ready for harvest in about 2 days. To properly harvest a white mushroom, you snap, you turn, you rotate. There's nothing better than a fresh mushroom just off the bed. Very buttery, very natural, very earthy.
When the mushrooms have fully matured, Mother Earth begins harvesting them. The mushrooms are organized by type, size, and quality.
This is a portobello house. We've already harvested some creminis out of here, and the pickers do a very good job of carefully selecting to try and what we call open up these beds so that we can give all of the mushroom caps the proper space that they need without getting crowded out by competing mushrooms. And we can pick and harvest some every day. We do selective harvesting. We don't come in and we just take everything off at once. We very carefully develop our beds. We try and only touch these mushrooms one time. All of the harvesters have gloves. The gloves are changed 3 times a day. Food safety, again, becomes our highest priority at the picking level. Here you can see that the harvesters are carefully grading the mushrooms as they begin to pick the portobellos. We separate them between 2.5, 3.5, 4, 4.5, and 5-inch. We will actually have separate baskets for each of those size mixes. A lot of the mushrooms that don't go fresh go into a process, and Mother Earth Organic Mushrooms ends up in a lot of the brands that you know. Sometimes you'll notice when you buy a portobello that it has the stem attached, and sometimes you'll notice that the stem is removed. When you do get it out at home, you just need to remove the dirt level. The actual stem portion you can use, and you can chop it up, put it in your soups. When we gently break off the stem, you'll see that the different parts of the mushroom. This part here that you see attached to the stem is called the veil. The veil, at one point of a closed mushroom, was protecting the gill. The gill is that pinkish brown portion that you see. Inside these gills, they're just a bunch of separated membranes, and within that is the spores. The spores are what we then can take and make spawn and reproduce the mushrooms.
After being harvested, the mushrooms are sent a few miles away to Mother Earth's processing and packaging facility. Once there, mushrooms are cleaned, weighed, packaged, and shipped all over the United States.
Once the mushrooms have been received, the production floor then takes over. For each customer, we carefully select the grade that's required to make sure that we're adequately fulfilling their needs. Mushrooms come in at an average temperature of about 72 degrees. We need to get that down to roughly 36 degrees, 35 degrees as fast as possible. The vacuum cooler basically sucks the heat and the moisture out of the mushrooms. This is our retail room. We have 3 packing machines. They can produce up to 500 flats an hour. Here's an example of our metal detection. Tills were identified as potentially having hazards. We are an SQF certified facility. We have full traceability forward and backwards from the time of receiving of the mushrooms. We can tell by a scanning of any one of our code tickets, whether it's a shipping ticket or a packing ticket or a receiving ticket. I can tell you the life history of that mushroom.
From compost and casing to harvesting and packaging, organic mushroom production is a science, and the team at Mother Earth know exactly what they're doing. By paying close attention to details and harvesting their mushrooms at just the right time, Mother Earth provides nutritious and delicious mushrooms for your next meal.